Okay, this is the final section from Chapter 1, Section 1.7, and we talked about functions as tables and as rules, and today we're going to get to the last representation of function, that's functions as graphs. So your objective for today is going to be able to show a function as a graph, and then since we're kind of coming to the end of the chapter, to explain the 4 different ways that you can represent a function, and we're going to give examples. Now, you already know this, all right? But when you're given a table and it represents a function, you can show the function or the numbers in the table as a graph. So what you're going to get are input and output numbers. Those are the x and the y values. And those are ordered pairs that we can put on the graph as a point. And you know this also, but just to review it again, really important thing is this, the x coordinate, that means going across, is the input, and the y coordinate is going to be the output. So here, input, output, input refers to the x coordinate, and the output refers to the y coordinate. So let's go right into this. So we're going to take a table, and you're going to see we got input values, output values, and we're going to combine those to make ordered pairs. So if I put in 1 and I get out 2, the ordered pair is going to be 1, 2, or 1 over 1 up 2. If I put in 2, I get out 3, so the ordered pair is going to be 2, 3. And if I put in 4, we're going to skip 1. We put in 4, I get out 5, so the ordered pair is going to be over 4 up 5. So now all we're going to be doing is taking those points and putting the points on a graph. So there's over 1 up 2, over 2 up 3, and now we have over 4 up 5. Okay? So the representation of the graph right now is going to be, of the function, is as a table, which is right over here, obviously, and then taking the table, the values from the table in ordered pair form, and put them into a graph. And if you're thinking about the rule, well, the rule is pretty easy to see. It's just y is equal to x plus 1. We're adding 1 to x in every one of these instances. So this would be y is equal to x plus 1. All right, again, something you already know also, the horizontal axis that's going across the bottom is the x-axis, and the one going up and down is the vertical axis, that's the y. So we have the inputs going across, we have the outputs going up, and again, we're using x and y. A lot of this is just review for you. So now we're going to do, and I'd like you to take out a piece of graph paper for this, or draw a graph onto your paper. We're going to graph the function y equals 1/2 of x, and the domain values are going to be 0, 2, 4, 6, and 8. We'll talk more about the values in just a second. So the first thing we have to do is make a table. So we know our functions y is equal to 1/2 of x, and we know our domain values are going to be 2, 4, 6, and 8. And this is one of those instances when, and you're going to see this as we move throughout the book, that when you have a fractional, kind of a coefficient that's a fraction, like 1/2, usually it's easier to put in even numbers, like if it's 1/2, because 1/2 of an even number always comes out to a whole number. So you'll see those numbers in a minute. If this was 1/3 of x, we might want to put 0, 3, 6, 9, 12, because those numbers can be divided by 12. So just something for future reference is as we're going through the book and we're dealing with these kinds of functions. So now the y values, if I put in 0, I get out 0. If I put in 2, 1/2 of 2 is 1. 1/2 of 4 is 2, 1/2 of 6 is 3, and of course 1/2 of 8 is 4. So if you're thinking and you're remembering what we did over the last section, these values, 0, 2, 4, 6, and 8, are the domain values, and 0, 1, 2, 3, and 4 is the range, or are the range. Okay? So our goal was to graph the function. So now that we have the table, and notice that you can take the table and put it in horizontal fashion or vertical fashion, right? And we're just going to use those numbers as the ordered pairs, and we're going to graph them. So it's really a pretty simple thing. Another thing you might notice is that since we're using fractions, or 1/2 as our coefficient, the line's not as steep. So you notice that as the number that's in front of the x, the coefficient, is a smaller number, it means the line's going to be less steep. And we'll, again, talk more about that when we get to chapter 4 of the book, too. Okay? So this really isn't all that difficult, hopefully. And again, probably something that you've kind of done in the past. We're just using different notation and different vocabulary for what we're doing. Okay? So now we're going to take our second example. This time it's y equals 2x minus 1. This time the domain is going to be 1, 2, 3, 4, and 5. So we're going to make a table, make a graph, and find the range for the function y equals 2x minus 1. So we've got our graph made. Again, take time, just pause this for a second and draw the graph on your paper. Here's our function. Remember, it's always a good idea to keep that written above the table as you're making your table. We know the x values, or the domain values, are 1, 2, 3, 4, and 5. And again, this is the kind of math hopefully you're doing in your head right now. If I put in 1, if x is 1, 2 times 1 minus 1, that's 1. 2 times 2 minus 1, that's 4 minus 1, that's 3. If I put in 3, 6 minus 1 is 5, and so on. Again, this is a pretty simple function. The math is pretty simple. What we're mostly looking at is how are we getting the numbers, okay? And again, keeping in mind all those important words like 1, 2, 3, 4, 5, these numbers make up the domain. 1, 3, 5, 7, 9, these numbers make up the range. And to graph it, just something simple like this. And again, for future effort, if you remember the last function we did, 1/2 x, that line, or the line that was created by the dots, the points, was kind of like a flatter line. Notice that as the coefficient gets larger, the the slope of the line, or the steepness of the line, gets a little bit higher. And again, that's something that you'll learn more about when we get to chapter 4. So far we've talked about having a verbal rule, right? That's double the number and take away 1 or something like that. Then we have the equation, or the rule. We can make a table, and we can put the function in the graph. So there's 4 different ways, or 4 different representations of the function that we're dealing with. Okay. Now we're going to kind of go backwards. This time, instead of drawing a graph, you're going to be given a graph and asked to find the rule that's kind of like represented by the graph. So take a look at this. And we can see that there's obviously, the 5 points kind of in a line. So the first thing we're going to do is make a table. So we draw our x and y table. And I know that the first point is over 1 up 2, over 2 up 3, over 3 up 4, over 4 up 5, and over 5 up 6. Those are the numbers that we put in. This should look familiar because we did this one earlier when we started the lesson. We can see that in the table, there's a relationship between the input and the output. And the relationship is this. Every time we go up 1 on the input, the output goes up 1 also. So the rule for the function is y equals x plus 1. And again, that was the function that we saw earlier when we first started this section. The domain are the numbers 1, 2, 3, 4, and 5. The range, obviously, are the numbers 2, 3, 4, 5, and 6. That pretty much sums up most of the last couple of sections of this chapter. Being able to find a rule, being able to make a table, being able to make a graph, understanding the domain, the range. Hopefully it's all clear to you, and if it's not, please make sure you come and see me so we can have a discussion about it. Okay, we're going to do the same thing again. So here's our graph. We have 2 of them. And this one looks a little different because it's going down instead of going up. So we have 1, 4, 2, 3, 3, 2, and 4, 1. So if you need to, make a table. And it's a little different. If you remember some of the things we studied last year, you'll know that this has a negative slope. That means it's going to be a negative x value. So see if you can figure that out. Then on this side, be really careful because the points go over 1 up 10, over 2 up 15. So these aren't going by 1s. These are going by 5s, the intervals here on the left-hand side. So if you need to take a second, make a table for each of these things. See if you can find out the relationship and the rule. Hit pause. When you're done, hit play again. You'll be able to see them because I'm going to put the answer up on the board in just a second, on the screen in just a second. Okay, were you able to figure it out? The first one was y is equal to negative x plus 5. So whatever x is, we make it negative and then add 5 to it. So negative 1, this was 1 over 1. Negative 1 plus 5 would give me 4. Negative 2 plus 5 would give me 3. Negative 3 plus 5 would give me 2. And negative 4 plus 5 would give me 1. On the other side, if we multiply x by 5 and then add 5 more to it, we can find each of the points that are graphed. So 5 times 1 plus 5 make 10. 5 times 2 plus 5 make 15. 5 times 3, 15 plus 5 make 20. And 5 times 4, 20 plus 5 make 25. Okay? Again, probably not the easiest thing to do. If you're just looking at the graph, it takes it makes a little bit of sense to take a second or two, make a table out of these things, and see if you can find the relationship within the table. All right, now we're going to end the lesson, obviously always with a word problem. So let's take a look at this one. So we got a graph. They want us to find the independent variable and the dependent variable. Then we have to know, what do we think the sales are going to be like in the year 2006? Now, we haven't seen the graph yet, so let's go to the next page and take a look at it. Here's a graph. All right. Now, another thing that's interesting about this graph, and you're going to see this throughout the book, is instead of writing like 1999, 2000, 2001, 2002, 2003, and so on, to keep the numbers down here as single-digit numbers, they're just saying the year since 1999. So 0 stands for 1999, 1 is going to be 2000, this is 2001, and so on. Now on the left-hand side, when you're reading the graph, this is $0.4 million, or $400,000, $800,000, $1.2 million. So if we take a look at this, and if you remember from the last section, the independent variable are the input numbers. So the independent variable this time are the years since 1999. The dependent variable are the dollars that we're selling, the sales. And there we have that there. Now, they were asking us also, what's it going to look like in the year 2006? Well, let's see. Here's 1999, 2000, 2001, 2002, 2003, 2004, 2005. 2006, if this graph continues, the trend continues, we should probably expect to see about 1.4 million, right? So since the sales are increasing, we think the 2006 sales will be more than 2005, and $1.4 million would be a pretty reasonable prediction, maybe a little higher than that, for the guitarist or to consider for their sales. Okay. So reading the graph, not the hardest thing, but again, man, there's just so many words. Okay. Now here's a summary of the 4 things we've done over the last few sections. Okay, we know we can represent a function by the words. So in this case, the output, that's y, is equals 1 less than twice the output, that's 2x minus 1. The equation, or the rule, is y equals 2x minus 1. We just said that. We can take that, substitute numbers in for x, and make a table. And then finally, we can take the numbers from the table, the ordered pairs from the table, and represent the function as a graph. So 4 different ways to represent a function. Remember, when you hear the word function, you think of the words input, output. Okay, finally, as we're wrapping up the chapter, don't forget these terms: independent variable and the dependent variable. The independent variable is what kind of causes the dependent variable. So in the previous example, the independent variable was the number of years since 1999, and what was dependent upon that was how much money they were going to sell per year. The output and the input, the domain and the range. Okay, so terms that are going to follow us throughout the entire book. We'll be dealing with functions all the way through. Hopefully this was mostly a review for you, except for maybe some of the vocabulary. Your homework, the last homework from this section, is on page 46. Check your map. I believe this homework's due on Thursday or Friday this week. You also have a test that day. If you have any questions, come and see me. The answers will be on the wall, so just check your answers with the ones on the wall, and make sure I get to check them too. So thanks for watching, and if you have any questions, come and see me.